Today we are going to learn about mastering Seaborn Heatmaps for data visualization. We'll explore how to create, customize, and interpret Seaborn Heatmaps, enhancing your data visualization skills.
Seaborn is a powerful Python data visualization library built on top of Matplotlib. It's particularly effective for creating statistical graphics and is a favorite among data scientists and analysts for its simplicity and versatility. Seaborn's importance in data visualization lies in its ability to create visually appealing and informative plots with minimal code. Unlike other libraries, Seaborn provides a high-level interface for drawing attractive statistical graphics, making it easier to explore and understand complex datasets. It offers features such as built-in themes, color palettes, and functions for visualizing univariate and bivariate data. By using Seaborn, you can enhance your data storytelling capabilities, making it an essential tool for data-driven decision-making.
Heat maps are graphical representations of data where individual values are represented by colors. They are particularly useful for visualizing the magnitude of data across two dimensions, such as in a matrix or grid format. To create a basic heat map using Seaborn, you first need a dataset in the form of a 2D array or a data frame. The Seaborn.heatmap function is used to generate a heat map, where you can pass your data, set axis labels, and define color gradients. For example, using a correlation matrix of a dataset, you can quickly create a heat map to visualize relationships between different variables. Understanding these visual patterns helps in interpreting complex data structures, making it easier to spot trends, patterns, and outliers. By the end of this section, you'll be able to create a simple yet effective heat map using Seaborn. Colors play a crucial role in data visualization, as they can highlight important data points and trends. In Seaborn, customizing color palettes allows you to enhance the interpretability of your heat maps. Seaborn offers several built-in color palettes, such as blues, reds, and viridis, each suitable for different types of data. Choosing the right color palette depends on the dataset and what you want to emphasize. You can also create custom palettes using Seaborn.color_palette to fit your specific needs. A well-chosen color palette can make your heat map more readable and visually appealing, ensuring that the viewer's attention is drawn to the most critical areas. By experimenting with different palettes, you can significantly improve the clarity and effectiveness of your data visualizations. Annotations are used in heat maps to provide additional context by displaying the actual data values on the cells. In Seaborn, you can add annotations by setting the onNote parameter to true in the heatmap function. This feature is particularly useful when you need to present data in a detailed manner, as it allows viewers to see exact values alongside the color gradient. You can further customize annotations by altering text size, color, and format using parameters like FMT, font size, and color. For instance, setting FMT equals .2f formats the numbers to 2 decimal places, ensuring clarity and precision. Annotations enhance the interpretability of heat maps, allowing you to communicate your findings more effectively. By the end of this section, you'll be able to create comprehensive heat maps with informative annotations.
Styling is a vital component of creating effective heat maps, as it impacts the overall readability and visual appeal of your visualizations. Seaborn offers a variety of aesthetic options that allow you to fine-tune the appearance of your heat maps. You can adjust the plot size using the fig size parameter, which is particularly useful when dealing with large datasets. Additionally, you can modify axis labels, ticks, and titles to provide more context to your visualizations. Seaborn also supports theme customization, allowing you to apply predefined themes like dark grid, white grid, or your custom style. These styling options help in aligning your visualizations with the intended audience and presentation context, making your heat maps not only informative but also visually engaging. Missing data is a common issue when working with datasets, and it can significantly affect the accuracy and interpretability of heat maps. In Seaborn, missing data can be managed by either ignoring, filling, or highlighting these gaps. One approach is to use the mask parameter to hide missing values, ensuring that they do not distort the heat map's appearance. Alternatively, you can fill missing values using techniques like interpolation or the dataset's mean or median. Seaborn also allows you to indicate missing data by changing the color of missing cells, making them easily identifiable. Handling missing data effectively ensures that your heat maps accurately reflect the underlying patterns and trends, providing reliable insights for data-driven decision-making. Visualizing large datasets can be computationally intensive, often leading to performance issues such as slow rendering times and reduced interactivity. To optimize heat map performance in Seaborn, it's essential to apply techniques that reduce computational load while maintaining data fidelity. One approach is to aggregate or sample data to a manageable size without losing significant information. Seaborn provides options to control the resolution of your plots, such as adjusting the map resolution or reducing the number of ticks. Additionally, efficient data handling, combined with optimized plotting settings, can significantly enhance performance. By implementing these strategies, you can create heat maps that are both high performance and informative, making them suitable for large-scale data visualization. Heat maps have a wide range of applications across various fields, making them a versatile tool for data analysis and visualization. In business, heat maps can be used to analyze customer behavior, sales performance, and market trends, providing actionable insights for strategic decision-making. For example, a retail company might use a heat map to visualize sales data across different regions, identifying high-performing areas and potential opportunities. In healthcare, heat maps are valuable for visualizing patient data, such as tracking disease outbreaks or analyzing treatment outcomes. Scientific research also benefits from heat maps, particularly in genomics and proteomics, where they are used to visualize complex biological data. By examining these case studies, you can understand how heat maps are applied in real-world scenarios and learn to interpret them effectively for your data visualization needs. In conclusion, mastering Seaborn Heatmaps for data visualization empowers you to transform complex datasets into informative and visually appealing graphics. Throughout this video, we've explored the fundamental aspects of creating and customizing heat maps, including color palettes, annotations, styling, and handling missing data. We've also discussed optimizing performance for large datasets and examined real-world applications across various industries. By harnessing the capabilities of Seaborn, you can enhance your data analysis skills and make data-driven decisions with confidence. Remember, practice is key to mastering these techniques, so continue experimenting with your datasets to uncover valuable insights. Thank you for joining us in this journey to mastering Seaborn Heatmaps.